Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents Problem 18. If you want to access these exams anywhere in the world, go to nysedregents.org. Click on the appropriate tabs and all the tests are there freely available to you. Here's the problem. As x increases beyond 25, which function will have the largest value? Number one, f of x equals 1.5 to the x, or g of x equals 1.5x plus 3, or choice 3, h of x equals 1.5x squared, or choice 4, k of x equals 1.5x cubed plus 1.5x squared. This is a question that you should be able to do just on paper. Or on the calculator. So that's one of the things that they're looking for. Can you figure out a way to do this problem? And I want you to stay tuned to the second part. I'm going to do an extra problem that's going to say something very important about this problem. But we could do this 1.5 to the x and just compare the values. That's the way you should do this. You should not sit there and guess on this question. Why bother guessing if you could actually let the calculator evaluate it for you? I'm going to eliminate this just offhand because this is a linear function. There's no way that this is going to be bigger than any exponential or any quadratic function. But let's see, 1.5x plus 3. Okay, this is faster with the pen. Cool. 1.5. But you might not know which is bigger. The other ones, the quadratics or the cubics. 1.5x cubed. I already know that choice, this is the largest value. Okay. I started typing before comparing, so I know. I'm gonna have to type in choice 4 anyway, but I know choice 3 is not the answer. If you can guess why as I'm typing. So I know choice 3 is not the answer because choice 4 has a positive number plus the same function in choice 3. So choice 4 has to be bigger than choice 3. So I know that's not going to be the answer. But let's compare table set, independent. I'm going to set it to auto. And then I'm going to scroll. That's it. Table. And let's see. I'm going to scroll to 25. Okay, and I know choice 2 is definitely not the answer as we crossed it out. Choice 3 is already crossed out. Choice 4 could be the answer, 24,375. So I'm going to delete choice 2 and choice 3 at this point, okay, to make it easier for me to read. Choice 2 and choice 3. And the table will clear choice 2 and choice 3 even from the table, so I can compare side to side. Choice 4 is slightly bigger at x equals 25. Let's see if we keep going though. It's still bigger. Actually, it's significantly bigger now, choice 1. Choice 1 actually gets pretty large pretty quickly. And now it's in the exponentials. This is in the millions. Choice 1 is in the millions already. And just not very quickly, now it's in the tens of millions, whereas choice 4 is in the hundreds of thousands. Definitely the answer is choice 1. Okay, so I hope you got this. This is really kind of the way to do it, but there is another way to do it. There's a piece of knowledge that helps, and this extra problem is the one that's going to help us clarify that. This says which function will have the largest value for very large values of x. 1.5 to the x, 105x plus 20, 105x squared, 105x cubed minus 10x squared. The fact that this is subtracting 10x squared might be a red herring because the fact is that cubic functions grow so much faster than quadratic functions. So this will eventually, this 10x squared will be insignificant compared to the 105x cubed eventually. So don't eliminate choice 4 just because of the minus 10x squared. Here's the other thing though. Here it says very large values of x. It doesn't even give us what this means. So we have to think about what that means. Remember that numbers are very large. The law of large numbers, essentially. So we can think of large numbers as being 20 or 50, or some people might say 100. How about 1,000 or 10,000 or 10 million or 10 billion or 10 trillion for values of x? But then we can't even plug in some of those numbers because they're so large that the calculator can't even handle them. So what do? Here's what we do. We look at the type of function that this is. This is an exponential. Okay. This is a linear. This is a quadratic. And this is a cubic. And this is the statement that you need to know, that exponential functions eventually grow more quickly than any polynomial. So I shouldn't say any in this case. Any is a correct word. How about every, though? Every polynomial. Exponential functions eventually grow more quickly than every polynomial. Exponential functions, okay, exponential functions with a positive exponent. And how about a base greater than 1? Okay, fine. They eventually grow more quickly than every polynomial. Every polynomial. So the fact that this is cubic, it's not even relevant. It could be 105x to the 100 billionth. That's still a polynomial. Eventually, 1.05 to the x will surpass every polynomial. So that is the answer. That's the thing that you really need to know for any of these problems. It's a really nice, useful tool to have for this class, for geometry, for algebra 2, for pre-calc and calculus, and for every science class that you'll ever take that involves math. So this is the answer. That's it. Thanks for watching. Look, I know you can do it. Keep working at it. Stay tuned for the next problem starting right now.